My dear students, welcome back to our channel. In this video, I will be explaining the Bachelor of Computer Applications 4th semester subject Artificial Intelligence as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 2. Short questions. 1. What is game playing? Game playing in artificial intelligence, AI, means using computer programs to play games and make smart decisions, just like humans. AI learns the rules of the game and tries to win by thinking ahead and choosing the best moves. For example, in chess, AI systems like Deep Blue or AlphaZero are trained to calculate the best possible moves based on current positions and predict how the game will unfold. The computer uses strategies to beat the opponent. How it works? 1. The AI looks at the current state of the game. 2. It then makes possible moves and evaluates them. 3. It chooses the best one based on rules and strategies. Example. In tic-tac-toe, AI knows the best move to block or win by analyzing the board's state. Easy tip to remember. Game playing AI is equal to smart moves plus winning strategy. Game playing AI is like a computer opponent that always plays smartly. Next important short question is: 2. What is inheritable knowledge? Inheritable knowledge in AI refers to knowledge or skills that can be passed down or shared between different systems, programs, or agents. It's like how children inherit knowledge or skills from their parents, or how students learn from teachers. In AI, it means that a system can learn from past experiences and use that knowledge in future tasks without needing to start from scratch. The system inherits useful information to solve similar problems faster and more efficiently. Example. Imagine a robot learning to clean a room. It first learns how to clean a small area, then passes this knowledge to another robot. The second robot doesn't need to learn from scratch. It inherits the knowledge and cleans better and faster. Easy tip to remember. Inheritable knowledge is equal to learning from the past to improve in the future. It's like learning from a teacher so you can do your homework better next time. Next important short question is: 3. What is resolution? Resolution in AI is a method used to solve problems by finding contradictions in logical statements. It's like trying to prove something wrong to find the truth. In AI, we use logical statements, facts or rules to solve problems. If we have two statements that cannot both be true, resolution helps find that contradiction, and we can eliminate wrong possibilities to get to the solution. Example. Imagine two statements. 1. If it rains, the ground will be wet. 2. The ground is not wet. To check if these are true together, resolution helps us find the contradiction. If it's true that it rains, but the ground is not wet, one of the statements must be false. This contradiction helps us solve the problem. Easy tip to remember. Resolution is equal to finding contradictions to prove or solve problems. It's like detective work, finding clues that don't match to uncover the truth. Next Unit 2. Long questions. First important long question is: write about the importance of game playing in AI. Game playing in artificial intelligence, AI, is important because it helps AI systems learn how to make decisions, plan strategies, and solve problems. Games are a great way to test and improve AI, as they provide clear goals, rules, and a way to measure success. Why game playing is important in AI? 1. Helps develop decision-making skills. In games like chess or tic-tac-toe, AI needs to think ahead, evaluate different moves, and choose the best one. It simulates real-life decision-making where the AI weighs the pros and cons of different options. 2. Teaches strategy planning. In games, especially complex ones like Go, AI must plan long-term strategies, much like how humans plan for big projects or challenges. By mastering games, AI learns to think several steps ahead, which is important in many real-world situations. 3. Improves learning and adaptation. AI uses techniques like machine learning and reinforcement learning during game playing. The AI plays many games, learns from its mistakes, and improves its strategies over time. This helps the AI to adapt to new situations. 4. Testing ground for algorithms. Games are controlled environments where AI algorithms can be tested easily. For example, Deep Blue, IBM's famous AI, beat the world chess champion in 1997, proving the effectiveness of AI algorithms in complex problem solving. 5. Real-life applications. The strategies AI uses in games can be applied to real-life problems, such as robotics. AI can control robots to navigate obstacles. Finance. AI can predict stock market trends. Healthcare. AI can suggest treatment plans by learning from past medical cases. Example: AlphaGo, developed by Google, defeated the world champion in the game of Go, which is much more complex than chess. This showed that AI can solve incredibly difficult problems, even those requiring creativity and intuition. Easy tip to remember: game playing in AI is equal to learning decision-making, strategy, and problem-solving. In short, game playing helps AI develop skills that are essential in many real-life applications, from solving complex problems to improving everyday tasks. Next important long question is: 2. Explain about adding alpha-beta cutoffs. Alpha-beta pruning is a technique used to make AI game playing faster and more efficient, especially in minimax search algorithms. The idea is simple. When searching for the best move in a game, like chess or tic-tac-toe, we don't need to explore all possible moves. We can cut off branches of the game tree that are not useful, saving time and resources. What is alpha-beta cutoff? When AI looks at a possible move, it evaluates all future possibilities. However, alpha-beta cutoff helps the AI prune branches that won't lead to a better solution. It works by keeping track of two values: alpha, the best score that the maximizing player can guarantee so far; beta, the best score that the minimizing player can guarantee so far. If at any point alpha becomes greater than or equal to beta, we cut off that branch, meaning we don't need to explore it further. This saves time because we avoid unnecessary calculations. How alpha-beta cutoff works? 1. The AI starts with a search tree, where each node represents a game state. 2. It evaluates possible moves, branches of the tree. 3. As it goes deeper, it keeps track of the best scores for both players, maximizing and minimizing. 4. If it finds a branch that cannot improve the outcome, because it's worse than alpha or beta, it cuts off that branch. Example: imagine you are playing a chess game. Maximizing player, AI, wants to get the best possible score. Minimizing player, opponent, wants to get the lowest possible score. During the search, if the AI finds a move where it's already sure it can achieve a score better than any move the opponent can force, it will cut off the search of moves where the opponent can achieve a higher score. This way, the AI doesn't waste time on unimportant options. Advantages of alpha-beta cutoff. Speeds up the search process by reducing the number of moves the AI needs to evaluate. Improves efficiency without losing accuracy. Easy tip to remember. Alpha-beta is equal to prune unnecessary moves, saving time while still finding the best solution. So, alpha-beta cutoff helps AI make smart decisions faster, improving its ability to play complex games efficiently. Next important long question is 3. Discuss about iterative deepening. Iterative deepening is a search strategy used in AI that combines the strengths of depth-first search (DFS) and breadth-first search (BFS). It's an approach that helps find the solution to a problem step by step, but it's more efficient than searching all possibilities at once. How it works. In iterative deepening, the AI searches for a solution in layers or depths. It starts by exploring depth 1, just the first step, and gradually increases the depth, searching deeper and deeper with each iteration until it finds the solution. Steps in iterative deepening. 1. Start with depth 1. Search just one step deep. 2. Increase depth by 1. Repeat the search, but now go to steps deep. 3. Continue until the solution is found. This process allows the AI to find the solution quickly without needing too much memory, which can happen with BFS or getting stuck in infinite loops, like DFS might. Example. Imagine you are looking for a book in a library that has many floors. Depth 1, you check only the first floor. Depth 2, you then check the first and second floors. Depth 3, next, you check the first 3 floors, and so on. With each step, you expand your search area. This is how iterative deepening works, gradually increasing the search depth until you find what you need. Advantages of iterative deepening. Memory efficient, unlike BFS, which stores all nodes at once. Iterative deepening only needs a small amount of memory at each level. Guarantees the shortest solution, like BFS, it finds the solution with the least steps. Prevents infinite loops, it avoids the problem of getting stuck in loops, which can happen with DFS. Disadvantages of iterative deepening. Repetitive search, it can repeat some work at each depth level. Slower than DFS for deep solutions, it may take more time to find the solution compared to DFS, especially if the solution is far. Easy tip to remember. Iterative deepening is equal to combine DFS's low memory with BFS's shortest solution. So, iterative deepening is like expanding your search area step by step, ensuring you never miss the best solution while saving memory. Next important long question is 4. What are the different approaches to knowledge representation? In artificial intelligence, AI, knowledge representation refers to how we store and organize information so that machines can understand, reason, and make decisions. There are different methods or approaches to represent knowledge in a way that computers can use effectively. Let's explore the most common ones. 1. Logical representation. In this approach, we use logic to represent facts. The idea is to break down knowledge into propositions, simple statements that can be true or false. This helps the AI reason logically. Example. The sky is blue can be represented as sky_blue is equal to true. If sky_blue is equal to true, then it's a nice day. This is simple but powerful, often used in expert systems and theorem proving. 2. Semantic networks. A semantic network represents knowledge in a graph-like structure, where nodes represent objects or concepts and edges represent the relationships between them. This helps AI systems understand the connections between different ideas. Example: dog has legs. Dog is a type of animal. Semantic networks are great for showing relationships, like taxonomy, classification of objects. 3. Frames. Frames are like structured data or templates that represent information in a more detailed way. They are similar to objects in programming, with slots, attributes, and values data. Example: a frame for a dog might have slots like name, Rex; breed, Labrador; color, brown. Frames allow AI to handle more complex structures of information. 4. Production rules, if-then rules. In this approach, knowledge is represented as a set of rules that describe actions to be taken under certain conditions. These are if-then statements. Example: if the weather is sunny, then go for a walk. If the traffic is high, then take a detour. These rules help AI make decisions by applying conditions to real-world situations. 5. Logic programming, prologue. Logic programming uses formal logic, like predicate logic, to represent facts and rules. Prologue is a language designed for this, where AI systems can infer new facts from known ones using logical rules. Example: in Prologue, you could define father, John, Mike; father, John, Sarah; child, X, Y; father, Y, X. Here, AI can infer that Mike and Sarah are children of John. Easy tip to remember: knowledge representation is equal to how AI stores and uses information. Each approach is like a tool for different jobs, depending on the type of knowledge AI needs. So, in AI, how we store knowledge matters because it affects how well AI can understand, reason, and make decisions based on that knowledge. Next important long question is: 5. Write about frame problem in AI. The frame problem in artificial intelligence, AI, refers to the challenge of how to efficiently represent changes in the world when something happens, without having to update everything that doesn't change. When AI systems try to represent and reason about the world, they often need to update the information in a way that's computationally efficient. However, it becomes a problem when the system has to explicitly list all the things that remain unchanged after an action, even though many things don't change at all. Example to understand the frame problem. Let's say you have a robot in a room. It picks up an apple from a table and moves it to a shelf. Action: the robot moves the apple. What changes? The position of the apple. What doesn't change? The room's color, the shape of the table, and the fact that the robot is still in the room. Now, the challenge is: how does the robot know that nothing else, like the shape of the table, has changed after moving the apple? If the robot had to check every single object in the room to see if it changed, it would take a lot of time and effort. This problem is called the frame problem: how to represent changes in the world without having to explicitly mention every single thing that stays the same. Why is it a problem? 1. Efficiency. AI needs to be able to focus on what's important and ignore the rest. 2. Complexity. In a complex environment, keeping track of everything that doesn't change is hard and inefficient. How do we solve it? AI researchers use special techniques to handle the frame problem. One solution is to use assumptions. The system assumes that most things stay the same unless there's a specific reason to believe otherwise. In some cases, AI systems represent only the things that change, like the apple's position, and leave everything else unchanged. Real-life example. In a self-driving car, The car needs to update its knowledge when it changes lanes or stops. It doesn't need to update every detail, like the car's interior, but focuses only on relevant changes, such as its position on the road and nearby vehicles. Easy tip to remember. Frame problem is equal to how to represent changes without overloading the system with unnecessary updates. The frame problem is a key challenge in AI, but with smart techniques, AI systems can focus on what's important and ignore what stays the same.